Hello students, today we will be doing example 1.7. In the last lecture we did example 1.6. The example is almost similar to example 1.6. In example 1.6 we found the force acting on the charge kept at the center. Here also we have three source charges. Say the charge at A is Q, the charge at B is Q. They are the like charges, both are positive given. The charge at C is minus Q, so it is unlike compared to A and B. In this question, you have to find out the force acting on each charge. So from the figure it is clear there will be the two forces acting on charge at A, which will be due to B, due to C. Similarly at B, there will be two forces due to A, due to C. Similarly at C, there will be two forces. So overall, you have to find out the six forces in the given question. So again we refer the geometry. The triangle given is equilateral triangle. And as I said earlier, the first thing is we have to find out the magnitude of force. Now if we see the magnitude of force between A and C, I am talking about the magnitude. So it will be K, Q upon L square. Similarly, the force between B and C, it can be attractive or repulsive, but I am talking about the magnitude. So that is again K, Q square upon L square. Similarly, the force between A and B, K, Q square upon L square. So the first thing is we have to see the magnitude of forces, and then we will move to the direction as we did in example 1.6. So the first step, I will be writing the magnitude of force of attraction, the magnitude of force of attraction or repulsion between any two pairs of charges is same. So if there is an unlike charge, there will be attraction. If there is a like charge, there will be a force of repulsion. However, the magnitude is same. So let that magnitude be given as F. So F is equal to KQ square upon L square. Now this is the magnitude of force. So I denote it by equation 1. Now I have to find out the force acting on the charge Q1. So clearly the charge at B will repel A. So this will be referred as force acting on 1 due to 2. That is a Coulomb's law. And we know how to write this subscript. It will be the force acting on 1 due to 2. So there is a force of repulsion. C is negative charge. So this will be the force acting on 1 due to 3. So there are two forces I have drawn at point A. This is an equilateral triangle. So this angle is 60. Now the magnitude of 1, 2 and the magnitude of 1, 3 is same. That is this. Magnitude is same, but the direction is different. So the resultant of 1, 2 and 1, 3 will be in between this. And as per the symbol, I will write it as F1 vector. And it will be read as the resultant force acting on charge at A. So let F1 be the resultant force acting on Q at A. Therefore, F1 vector is equal to F12 vector plus F13 vector. As far as magnitude is concerned, it is same. You can check 1, 2, it will be same. 1, 3, it will be same. The magnitude is same, but the direction is different. So we have to apply the law of parallelogram. Now I have to see the angle between 1, 2 and 1, 3. So this angle is 60. So clearly this angle should be 120 degree. So the angle between 1, 2 and 1, 3 is 120. So I will find out the resultant magnitude. So F1 will be equal to under root F12 square plus F13 square plus 2F12 1 F13 cos of 120 as we did in the previous sum. Cos 120 is minus half. So 2 will get cancelled. Also 1 2 is equal to 1 3 is equal to F. That is equation 1. So this is F square plus F square minus, I am directly writing cos 120 is half. So 2 cancelled F square. So here cos of 120 is minus half and F12 is equal to F13 is taken as F. And also for the immediate or rapid calculation, you remember whenever the angle is 120 and if both the magnitude is same, then this is cancelled and you will get the same magnitude. So for rapid calculation you have to remember, if the two vectors have an angle of 120 and they have a same magnitude, the resultant comes out to be same as that of individual forces, that is F. So therefore, mod of F1 is equal to kq square upon L square. Same magnitude. Now I write it in a vector form, that is F1 vector is equal to k q square upon L square. Now if I see the direction, this direction of F1 is parallel to BC. So if I extend this BC and if I extend this F1, both comes out to be parallel. So I will take a help of a unit vector and I name it R1 cap. So this is my answer for the resultant force acting on A. Let us give it equation 2. Here R1 cap is along, now it is parallel to BC, so I write the direction along BC. So R1 cap is a unit vector along BC. So this is how I find the resultant force acting on charge kept at point A. Similarly, let us find out the force acting on B. So, again there will be a force of repulsion. Now this symbol can be written as F21 and it will be read as force acting on 2 due to 1. This will be attracted towards C. So this is force acting on 2 due to 3. Again resultant. So it is similar to this. This angle is 120. It comes out in between this two, that is F2. So this is F2. If we find the magnitude of 2, 1, 2, 3, it comes out to be same. So for the second part, I am making the change here. You have to write down the second part also. Now I write let F2 be the resultant force acting on Q at B. Now I name it F2. The symbol becomes force on 2 due to 1, force on 2 due to 3. You have to write down the second paragraph. I am making changes here. So this will be written as 2, 1, 2, 3, 2, 1, 2, 3. Again the magnitude of 2, 1 and 2, 3 is F. Answer again comes out to be F. So the resultant force F2 is same as that of the force acting on A. So this is F2. Now if I want to write down the equation for F2, I will write, this was for our A portion. So F2 vector can be written as kq square upon L square. Now I make this direction as R2 cap and this equation is 3. Here R2 cap is unit vector along Now this F2 comes out to be parallel to AC. So it is along AC. So this is the force acting on the charge at P. Now if you see, the magnitude is same but the direction is different. Now we have to find out the force acting on C. Now C is a negative charge, so it will be attracted towards A and B. So this is force acting on 3 due to 1. This is force acting on 3 due to 2. The angle between this is 60 degree now because it is an equilateral triangle, and resultant comes out to be in the downward direction. Let us name this as F3. So again the third portion, let F3 be the force acting at on minus Q at point C. So F3 is a resultant force. In the vector form, I will write F3 is equal to F31 plus F32. Again, they have some angle between them. So mod of F3 is equal to under root F31 square plus F32 square plus 2F31 F32. Now if you see the diagram, the angle between them is 60 degree. The question is, in the question they have given it is an equilateral triangle, so cos 60. Now this can be written as, again we check the magnitude 3132, 3132, the magnitude is same. So this can be written as f square plus f square plus 2f square, and cos 60 is half. So within bracket we mentioned it, cos 60 we have taken half, and F31 is equal to F32 is equal to F. Now this 2 get cancelled, so your answer comes out to be root 3 times F. So if the angle between the two vectors is 120, the resultant comes out to be same. Now for rapid calculation you have to remember, if the angle is cos 60 and the magnitudes of the two vectors is same, the answer comes out to be root 3 times. So this is equal to root 3 times kq square upon L square. This is the magnitude of the resultant force acting on point C. In the terms of direction, now I am removing this mod sign, I have to mention the direction. So this is root 3 kq square upon L square. Now let us name this direction by a unit vector r cap 3. This will be your answer, the resultant force acting on the point C. Here RQ is a unit vector along the direction bisecting. Now if I extend this direction F3, it will bisect AB. So it is a unit vector along the direction bisecting angle CBA. So this is CBA and this is a bisector, that is R3 cap. Direction is downward. If we draw a Cartesian coordinate system here, I can also call it is along the negative y-axis. But because the Cartesian coordinate system is not drawn, I am writing it is a unit vector along the direction bisecting angle CBA. So this is how we find out the resultant force acting on the individual charges. So on each charge there are two forces acting. Now again, if I see this three forces, let us draw this three forces. This is your F2, this is your F1, and this is our F3. Now, without changing the direction, if I am able to make a closed loop, so this is my F2 again, this is my F1, and this is my F3. So individually this was the direction of three forces. Now this is my F2. I picked up F1, kept its tail on the head of F2. I take F3, keep the tail on F1 and head on F2. Again it forms a closed loop. So if I need to find out the resultant of all the three forces, then it comes out to be 0, similar to what we have done in example 1.6. So if there are n vectors forming a closed loop, then the resultant comes out to be 0. So this is what we have for example 1.7. Now let us move to example 1.8. Now in example 1.8 we have two parts. In the first portion it is given that the electron is falling through a uniform electric field. So if I take one electron, this electron is falling downward. Now if electron is falling downward and the effect of gravity is neglected, we are neglecting the effect of a gravity, then for uniform field, this portion, the downward portion should be positive and the upward portion should be negative. Then the electric field lines can be drawn. We know the electric field lines emerge from positive charge and it terminates at the negative charge. So this is the electric field lines. However, they have given you the diagram in the question itself, but it may be possible that the diagram is not given. So if it is said that the electron is falling downward and neglect the effect of gravity, it should be understood that the charge at the bottom should be positive and the charge at the top should be negative. Then only it is possible to create a uniform electric field. So this is a uniform electric field which is in the upward direction. Now the gravity is not there. If we have a gravity, then the force acting due to gravity is mg. That we know, it is a gravitational force. But the effect of gravity has to be neglected as given in the question. So the only force acting on this electron is an electric force. Due to electric force, it is moving downward. Now what is the electric force acting on an electron? So we apply the definition of electric field. So Fe is equal to QE. That is what we have done for electric field intensity. Now here it is one electron. So I will write the force acting on electron. This is force acting on electron. So subscript E indicate electron. So Fe is equal to, now charge on one electron is a fundamental electric charge which is denoted by E. So Fe is equal to EE. The question is, find out how much time an electron will take to fall from a height 1.5 centimeter. So the electron is falling from a height 1.5 centimeter. So h is equal to 1.5 centimeter. Now if we take the concept of 11, it is clear that if a height is given, you need to find out the time. It is a free fall, so initial velocity is 0. So it can be done by applying the equations of motion. The first equation of motion have a final velocity. So it is insignificant to use here. Similarly, the third equation also have a final velocity. So it is insignificant to use that equation here. We have a height. We need to find out the time of fall. Acceleration, we can find out from this. So clearly, we can use the second equation of motion. So for second equation of motion, first I find out the acceleration of an electron. Now force can be written as mass of electron, acceleration of electron is equal to EE. Therefore, acceleration is equal to EE upon ME. So this is the acceleration acting on an electron. E is a charge on an electron, capital E is given, that is 2 into 10 is to 4 Newton per coulomb. The field is uniform. Since we have drawn these field lines equidistant and parallel to each other, mass of electron is a constant which we know. Since it is given, since electron is falling freely, so initial velocity V0 is equal to 0. Now what is the second equation of motion? H is equal to V0 t plus half at square. Now since we are dealing with an electron, I am using the subscript AET. This is T. Now V0 is 0. Therefore H is equal to half AET square. Therefore TE equation is twice H upon AE. AE is formed from equation 1. So this is our equation 2. Substitute equation 1 in equation 2. Therefore, TE is equal to under root. So AE I am substituting here. So 2H NE upon EE. So this is our formula for the time of fall. So I substitute all this value. TE is equal to under root 2 into H is 1.52 10 raised to minus 2 meter. Mass of electron we know 9.1 into 10 raised to minus 31 kg divided by charge of an electron, that is 1.6 into 10 raised to minus 19, and the electric field is 2 into 10 raised to 4. So this PE is equal to, now equating the powers and other terms, I can find out this value with the help of a calculator. So this value, if you calculate, it comes out to be around 2.9 into 10 raised to minus 9 seconds. That is about 2.9 10 raised to 9 means a nanosecond. So an electron will take about nanosecond to fall from a height of 1.5 centimeter in a uniform electric field. So here we have neglected the effect of gravity. So this is the first part of question 1.8. Now in the second part of the same question, it is given that an proton is falling freely. Now proton is falling, proton is positively charged. So we have negative charge at the bottom and at the top we take a positive charge. Either you say it is falling due to its repulsion or attraction due to the negative charges. Again the field are uniform, so I am drawing equidistance and parallel lines. This is an electric field. Now proton is falling freely. Again we are neglecting the effect of a gravity, so it is falling under the influence of an electric force. Again I will write force acting on proton, that is Fp is equal to QE. Again the charge on the proton is same, that is E, fundamental electric charge. So Fp is equal to EE. Therefore again force is mass into acceleration, so acceleration is equal to EE upon the mass of proton. So this is our equation 1. Again same way what we have done for electron. Now I am not again writing the theory portion. Again the fall is free, so for freely falling body again we are taking the velocity to be 0. So H is equal to half AP TP square. Now again we have to find out the time of fall of a proton. So therefore TP is equal to under root 2H upon the acceleration of a proton. So this is equal to under root 2H upon acceleration of proton, again EE and P, that is equal to under root 2 into, again the distance is same for this portion. The mass of proton is 1.67 into 10 raised to minus 27 kg. So that is a constant what we know. the charge is 1.6 into 10 raised to minus 19 into the electric field given is 2 into 10 raised to 4. Again, equating the power and the numericals value, you find that the TP comes out to be about 1.6 into 1.3 into 10 raised to minus 7 seconds. So this is the time taken by a proton. If it has to be converted into a microsecond, then TP can be written as 0.13 microsecond. So for a proton, the time of fall is microsecond, and for an electron, we have seen the time of fall is nanosecond. Also, by common sense, the electron is lighter as compared to the mass of a proton. So, electron will reach in a short interval as compared to the proton. So, proton take about microsecond to reach at the bottom, or it falls from a height 1.5 centimeter, and the electron will take only the nanosecond because electron is lighter as compared to proton. Now, in this we have neglected the effect of gravity. Now, in this example, we have considered that the proton and electron were falling in a uniform electric field and the effect of gravity was neglected. Now, suppose that an electron as well as proton both are falling only in the presence of gravity. We have only gravity. So the gravitational force will be MEG. This gravitational force will be equal to MPG. So this is the gravitational force acting on an electron or proton. Now if they both are falling through the same height in the presence of a gravity, then if I use the equation H is equal to V naught T plus half AT square. Now, because the gravity is present, it is a free fall, V naught is 0, A can be written as G, so H is equal to half GT square. So here it is clear that the time of fall is equal to 2H upon G. Now, whether it is an electron or proton, it does not depend on the mass, it depends on height and G. And G for electron as well as proton is same. So both electron and proton will fall through the same height and they will reach at the bottom at the same time, because in the presence of gravity the mass does not play any role. While in this situation, when we have considered the electric field, the mass play an important role. So this is in contrast to the gravitational force and electric force. Moreover, now the next part, why we neglect the effect of gravity. So if I consider the acceleration of the proton in the presence of electric field, so the acceleration of the proton is E upon ME. Now if I calculate this, let us calculate this here, 1.6 into 10 raised to minus 19 into 2 into 10 raised to 4 given. Mass of proton, let us take 1.6 into 10 raised to minus 27. So this 1.6 is cancelled. This is 2 into minus 19 plus 4, that is minus 15 plus 27. So it comes out to be 10 raised to 12 meter per second square. This is the acceleration of the proton in the presence of an electric field, while the acceleration of the proton in the presence of only gravity is 9.8 meter per second square. Now if I consider the acceleration of an electron, ME is smaller, the mass of electron is smaller, so this value comes out to be more than the value of this G. So in both the cases, acceleration due to acceleration of the proton is much greater than acceleration due to gravity. So in the presence of only gravity, the time does not depend on the mass of the particle, whether it is a lighter particle or a heavier particle, both will reach at the same time, because the formula is 2h by g. This is what we have conclude from this example. So in contrast to the electric field, this time is same whether it is an electron or proton. And other thing is why we are neglecting the effect of a gravity. So as we found the value, the acceleration of proton in the presence of electric field is about 10 raised to 12 meter per second square, while for gravity only, or in the presence of the gravity, its acceleration is only 9.8 meter per second square, which is very less. So in the study of electricity, we generally neglect the effect of gravity when the particles are falling freely. So this is what we have for example 1.8. Have a good day.